Hello, welcome on my YouTube channel. I've got some big news from the drone mapping world. WebODM, the open source powerhouse for processing drone images that many of us rely on, has officially decoupled from OpenDroneMap. This is a major shift, and honestly, it brings a lot of advantages for users. WebODM's lead developer announced that after years of limited support from the OpenDroneMap organization, the project is moving forward independently. This means WebODM now stands on its own, with its own infrastructure, its own repositories, and its own development roadmap. Let's talk about what this means for you and me, the people actually processing drone imagery. WebODM is promising more frequent releases, quicker bug fixes, and more responsive development cycles. No more waiting months for updates. For years, WebODM and OpenDroneMap were intertwined in ways that confused new users. Now WebODM is its own clearly defined project with its own download sources and its own branding. The roadmap includes better documentation, community directories, and more ways for contributors to get involved, from translations to code to regional user groups. And here's the part I'm personally most excited about, because if you've seen my older videos, you know exactly what I'm talking about. WebODM now offers native, user-friendly installers for Windows, macOS, and Linux. These installers are built and signed by the WebODM developers themselves. No more Docker gymnastics, no more command line acrobatics, no more why doesn't this container start headaches. Let's see how this works. On the WebODM website, click Download. There you can choose your operating system to see the available installation options. Here I use the Windows WebODM installer version 3.2.1. I get a warning from my Windows operating system that it's not yet a trusted software, but I will run it anyways. Accept the license agreement and click Next. Here it recommends to choose your largest hard disk because it needs quite some space also for processing the images. Click Next. I keep the default here for the Start menu. And then click Install. In the end, you'll see this screen and you can launch WebODM when you click Finish. Then it launches WebODM and first you get a warning about Node.js, which you need to give permission. And when it's successfully started, you will see this screen. Let's test our installation with drone data. There's a nice repository with example drone data that we can use. I'll provide the link in the description of this video. Here I'm going to use this zoo data. Simply download the zip file from GitHub and extract it on your own hard disk. In our WebODM dashboard, let's edit the name of the project and I call it zoo. I can give an optional description. Let's call it example. Save the changes. Then I select the images. I had extracted the downloaded file and there I find the images in a folder. I select all these images. They come with EXIF data with the GPS information, and this will be immediately plotted on a map in the dashboard so you can see where the drone images were taken. You can change the settings here for specific purposes of your drone processing to optimize it for multispectral analysis, volume analysis, or other things. And you can even further fine-tune this with Edit. I refer to the manual of ODM and WebODM to see what settings work for you. Here I use the default settings. Then I click Review. I'll check my settings here and they look okay, so I can click Start Processing. Processing starts with uploading the files to the processing node. And it starts processing, which will take some time. When the processing is completed, you will see this, and you can there download different outputs, such as orthophotos, surface models, or 3D objects, or you can click on the map to see the map in 2D, and you see a nice orthophoto that we've processed here on top of a satellite image from Google. And you can see the details when we zoom in. and I can click on the 3D view. Here in the pottery viewer we can see all our points, and we can easily navigate the 3D scene. Under cameras you can click on show cameras, and there you can see the position of the drone. There are a lot more settings in here also to measure. They're covered in other videos. And you can also generate a textured model. Unfortunately, here it crashes on my computer and I need to restart WebODM, probably related to my own hardware. After restarting WebODM, I go back to the task, and there I'm going to download some of the products and see how they look in QGIS. I'm going to download the orthophoto, and here you have some choices, and I'll download it as a GeoTIFF RGB, which is good enough for visualization in QGIS. Save it to your folder, and in the same way I'm going to download the surface model. It's a digital surface model as a GeoTIFF. Here I use the raw format. Save it to the same folder. And finally, I'm going to download the point cloud, which I can also open in QGIS and use for further processing. Here in QGIS, I can find the downloaded data. Let's first have a look at our orthophoto. Here it's loaded, and you can see the amount of detail, which improves when I zoom in further. The orthophoto is very detailed, and if I go to the layer properties, I can see what the spatial resolution is. And there you can see that it's 5 centimeters. Now let's load our digital surface model. Here it is. I zoom to the layer, and I'm going to render this as a hillshade because that's a very quick way to evaluate the result. Make sure you put the resampling of zoomed in and zoomed out to bilinear to not get too many blocks. There's still some blocky pattern here, so I switch on the early resampling. And here you see the result with a lot of details, and at the borders, of course, you see the triangulation artifacts, but that looks really nice. And then finally, we have the point cloud data in the LAS format. When you load it, QGIS is automatically converting it to a COP/C format that you can then use for further processing in the processing toolbox. I have other videos and a course at Udemy for point cloud processing and 3D visualization in QGIS. Here the point cloud has loaded, and you can also render it as a surface. And you can visualize it in the 3D view. I create a new 3D view, and when you drag your scroll button of your mouse towards yourself, you can tilt the landscape, switch off the background, go back to the 3D view, and here you can see all the points of the point cloud. In the 3D view settings, you can also render it as a surface, and here you see the interpolated surfaces. That looks great and very detailed, and I hope that this video was useful for you and that you see that WebODM is a fantastic open source product for processing your drone images, aerial photographs, and even photos that you took with your mobile phone.